Hello everyone. So today I am going to explain the learning target 8A. The 8A says I can draw the timing diagrams for three types of flip-flop J, K, D and T with asynchronous controls. So today I am going to explain the J, K flip-flop timing diagram and the characteristic table for that. So this will be going to be the negative edge trigger J, K flip-flop, which means the output Q changes only at the falling edges of the clock, as shown by the arrow. The blue arrow shows that the clock has a negative edge trigger. So the Q will gonna change at that negative edge only. So at the start, Q set state. So the initial value of Q will be 1. So it start from 1. Now here you can see J is 0 and K is 1. J is 0 and K is 1. So that is a reset condition. So the Q changes from 1 to 0. And for the second section, here you can see J is equals to 1, K is equals to 1. So when J is 1, K is 1, that is toggle condition. So Q changes to the opposite of its previous value. Since Q was 0, it's become 1. And then at the next following where J is 1, K is 0, that is a set condition. So Q remains 1. After that, J becomes 0 and J becomes 0 at the next following stage. So J becomes 0 and K becomes 1. So that's the reset. Q changes from 1 to 0, but here takes apart the pre. When the pre is low, pre is an asynchronous input. It overrides the clock and forces Q to 1 immediately without waiting for the clock edge. So Q has to become 0, but pre takes the part, so then it remains 1. But the next following stage, J is 0, K is 0. So this is not toggle, this is a reset. So then Q will become 0. So then the Q will be same, and finally pre is 1 at the high. So now we can say Q will gonna become low. So Q bar will be always opposite of the Q, like that. So now we can build the characteristic table for this diagram. So here we can put the J, K, clock, QT plus 1 and more. So when J is 0, K is 1, clock is always going down. Here we can see. So this will be no change more. When J is 0, K is 0, clock is down. J J0 K0, the mode is no change. Our next output stays the same as the current output. So 1 0, then no change. When J is 0, K is 1, clock is always down. The mode is the reset mode. So here we can say reset. Once again 0 1 1 0 reset. So when J is 1, K is 0, the mod is set, the next output becomes 1. And both are 1, so that's the toggle mode. 0 1 toggle. So that's the characteristic table for the diagram that we made. So overall, JK flip-flop changes only the clock edge unless an asynchronous input like pre overrides the normal behavior. So thank you for watching the video. That was all from my side.